Good morning, all. Today we are going to discuss the video lecture series of Thermodynamics 2, that is your performance of IC engine. So, our outlines are performance of IC engine, indicated power and brake power, frictional power, fuel consumption and specific fuel consumption, air fuel ratio and air consumption, and thermal efficiencies. So indicated power. So what is the indicated power? Now it is defined as the rate of work done on the piston by the combustion of charge inside the engine cylinder. So indicated power is mainly defined as your IP, which is mainly the rate of work done by the piston on the combustion of charge or your air fuel mixture inside the cylinder. Okay, it is determined from the indicated diagram obtained from the engine. It is also called as the gross power developed by the engine. So the formula of indicated power is indicated mean effective pressure into swept volume. So IP is equal to PM L into A into small n into K divided by 60, which is in kilowatt. Okay. So what is your PM? PM is your mean effective pressure. Mean effective pressure means we are not considering one pressure in every point of time. We are considering the average pressure during the piston movement. This is known as your mean effective pressure, which is called as your PM. Another one is L. Capital L is your stroke length, means the piston moving from bottom dead center to top dead center. This length is taken as your stroke length, that is your L. A is your cross sectional area of the cylinder bore. Total cross sectional area of the cylinder bore is taken as capital A. And the diameter, how to calculate the diameter? Diameter is your pi by 4 into d square. N is your number of working stroke per minute. Small n is called as your number of working stroke per minute. And for two stroke engine, N is equal to capital N, small n is equal to capital N for two stroke engine, and for four stroke engine, this is your N by 2. So what is capital N? Capital N is your RPM. Revolution per minute is known as your capital N. So capital N by 2 is for four stroke engine and capital N is for your two stroke engine, and K is your number of cylinder. So find out the indicated power. We are going to calculate the IP by using this formula PM into L into A into N into K divided by 60, which is in your kilowatt. Next one is your brake power. So brake power, it is the net power available as the engine shaft. The power which is developed by the IC engine is not actually utilized to run the engine. So the total power which is utilized to run the engine is known as your brake power. Okay. So it is the net power available at the engine. It is measured by the brake dynamometer. To measure the brake power, we are using generally the brake dynamometer, and mathematically the brake power, which is short form as BP, is calculated as brake load, that in velocity of the brake drum, that is 2 pi Rn by 60. Okay, so brake power is equal to 2 into pi into capital R into N into F divided by 60, which is also determined by 2 into pi into N into T divided by 60. So N here the terms are your F is your braking force, and R is your known as your effective radius of the brake drum, that is your half D plus D, capital D plus small d. So or capital D plus small d divided by 2, or what is your capital D? The capital D is the diameter of your brake drum, or small d is the diameter of the rope. T is your torque, which is the multiplication of force into radius, and N is also known as your speed of the engine shaft, that is your RP in RPM, which I have already told you in the previous slide. One is your indicated power and one is your brake power. Another one is your frictional power. So the power which is developed by the combustion of air fuel mixture is not utilized to drive the engine. So the losses which are happened is known as your frictional power. The losses which is happened in the engine is termed as your frictional power. So frictional power is the net power available at the engine shaft. It is the part of the indicated power which is used to overcome the friction. So frictional power mainly utilized to overcome the friction, which is mathematically expressed as frictional power is equal to indicated power minus brake power. So you can calculate the frictional power by calculating the indicated power and the brake power. Next one is your fuel consumption. So fuel consumption is determined, or it is known as the mass flow rate of the fuel consumed by the engine cylinder. How much fuel is consumed to develop some amount of power in the engine cylinder is known as your fuel consumption. It is calculated as the mass flow of the fuel consumed per hour. Okay, mathematically this is determined by mass flow rate of the fuel, that is m dot f is equal to v dot f into rho f into 3600 divided by del T, which is determined in kilojoule per hour. Okay, so what is VF? VF is known as your volume of the fuel used in time. In particular time, how much volume of the fuel is used. Rho F is your density of the fuel and delta T is your time taken. Okay, so this is known as your fuel consumption, which is determined by this formula. It is determined in kilojoule per hour. Okay, next one is your specific fuel consumption. It is defined as the ratio of mass of the fuel consumed per hour to develop unit power. So to develop unit power, how much fuel you will consume is known as your specific fuel consumption. Okay, so it can be calculated in term of brake power and indicated power also. The ratio of mass of fuel consumed per unit brake power produced is called as brake specific fuel consumption. So for unit brake power output, how much fuel you will input is known as brake specific fuel consumption, which is known as your BSFC. Otherwise, the ratio of mass of fuel consumed per hour is also produced in indicated specific fuel consumption is known as your ISFC. That is known as your ISFC and BSFC. BSFC is your brake specific fuel consumption and ISFC is your indicated specific fuel consumption. So BSFC can be determined by m dot f, that is your mass flow rate of the fuel, divided by indicated power. They determine the ISFC, and to determine the BSFC, that is your brake specific fuel consumption, we use the formula, that is your m dot f divided by brake power. M dot f is mass flow rate of the fuel. It is determined in the unit kilojoule per kilowatt hour. It can be determined in this term. Okay, next one is your air fuel ratio. Air and fuel ratio that will supply to the engine to run the engine. It is the ratio between the mass of the air to the mass of the fuel supplied to the engine. It lies between 12 to 19 for petrol engine and 20 to 60 for the diesel engine. This is the ratio of air and fuel. 12 and 19 is the ratio of air and fuel in case of your petrol engine, and 20 to 60 is the ratio of the air fuel in case of your diesel engine. So mathematically, air fuel ratio can be determined by m dot a divided by m dot f. What is m dot a? Now, m dot a is the mass flow rate of the air, whereas m dot f is the mass flow rate of the fuel. So m dot a divided by m dot f, you can determine that to find out the air fuel ratio. Okay. Next one is your air consumption. How much air is consumed during the formation of your power. So it is the mass flow rate of the air consumed by the engine cylinder. It is calculated as the mass of the air consumed per hour. Mathematically, it is determined by rho A into VA. What is your rho A? The density of the air. VA is the volume flow rate of the air. So volume flow rate of the air can also be determined by the formula pi by 4 d d square 2gh. It is determined in term of meter cube per second, and d0 is the diameter of the orifice, cd is the coefficient of discharge, and h is the head of the air. So in this class we will conclude at that point of time, and in next class we'll discuss further. Thank you.